Hey, Ray, just wanted to take a look at running through the aviation accident assignment uh, using Google Docs, Google Sheets, sorry, because I know that a lot of folks are using this particular software package. So we're going to go through the same thing. Instructions, again, we're calculating cumulative fatalities each year. We're completing a summary data table, and we're creating a set of graphs. Now, let's start over here with our accumulated fatalities. This code works exactly the same in Excel as it does in Sheets. So we're going to go ahead and start off by initializing the data set here. So we're going to say the accumulated fatalities since the year 2000. Well, that has been this number right here, the number of fatalities that occurred in the year 2000. So we click on that cell D6. And we take that data point. Now, it's suggesting an autofill, right? Notice it's just saying, hey, maybe you wanted to go back and take all those data points and bring them over here. That's not what we want to do. So I'll go ahead and click that X and reject that suggestion. What I do want to do next, I want to type equals, right? So for accumulated fatalities, I want to take the number of fatalities that happened in the previous year, and I want to add to that the number of fatalities that occurred in the present year. So I'm going to add cells G6 and D7 and go ahead and press enter. And now I can see that as of the year 2001, there have been 1,159 fatalities since the year 2000. Now, if I click on this little box in the lower right-hand corner and drag all the way to the bottom, the row numbers have automatically updated. So that way, as we can see, by the year 2019, there have been 9,728 general aviation accidents since the year 2000. Right? So now we have our running total. All right, our next step here, we want to complete the summary data table down there. So for our summary data, we're primarily looking at averages. So we'll start off with looking at averages per year. So first off, the average number of accidents that have occurred per year. Now again, same in Sheets as it is in Excel. We'll type A equals AVE, oops, sorry, typo, AVERAGE, not WE, and then we'll open our parentheses. And we want the average number of accidents that occurred. So we'll come over here to where our accident data is stored and highlight that data, close parentheses, and press enter. Now, again, it's suggesting some autofill. I don't want it to autofill, so we'll go ahead and reject that suggestion. We can see here that in any given year, on average, there have been 1,479 accidents in any given year between the years 2000 and 2019. Next, we'd like to take a look at the number of fatal accidents. So let's go ahead and press equals and type AVERAGE. Go ahead and open our parentheses and highlight that data set in column C for the average number of fatal accidents which have occurred. And we'll press enter. And so in any given year, within the 10-year period, there have been 277 fatal accidents. And so then we want to look at the number of fatalities. Oh, it's making a suggestion here. It suggests maybe we want to take an average. Well, I don't think that's quite what we want. We don't want to look at cells J13 and 14. Let's go ahead and type equals AVERAGE and go ahead and open parentheses, right? Now we're looking for the average number of fatalities that have occurred. So we're going to just look at the total fatalities. We're not going to differentiate between total fatalities versus the fatalities occurred among people who were aboard an aircraft. So we're just going to highlight the data in column D to take a look at the total fatalities that have occurred. And now we're going to go ahead and close our parentheses and see that in any given year, on average, 486 fatalities occurred. Now I want to take a look last but not least at the average number of flight hours which were accumulated during any given year. So we'll press equals, again, AVERAGE. Go ahead and open our parentheses and highlight that data in column F for a total number of flight hours in each year. And we'll go ahead and press enter. And we can see there are about 22,793,000 average flight hours in any given year. Now, the next thing I want to take a look at is the average numbers per flight hour. Now, these will probably be pretty small, right? Because aviation is considered to be pretty safe compared to, for example, driving a car. So let's just see what this comes out to. Now, this is a bit of sample code here. Let's go ahead and work through our first one. So we want to start off with equals. We want to see the average number of accidents which have occurred per flight hour. So let's start by grabbing the average number of accidents which have occurred per year. Now we're going to divide that by the average number of flight hours in any given year. And so we'll click on that. Now we'll go back here real quick and we're going to add the dollar signs in front of the J, so $J and $16. That locks it in so that we're always pulling from cell J16. Let's press enter. And you see it's a very small number. Now, if we click on the little box in the small corner of the cell, drag it down, notice again, we automatically update the row numbers, but because we locked in cell J16, like $J, $16, we're always pulling from that cell J16. So now we have a situation where we've figured out, okay, the average number of fatal accidents per flight hour, the average number of fatalities which have occurred per flight hour. Right? So in any given hour of flying, any given hour in the air, we see a very small number of accidents, small number of those have been fatal, and a small number of people have died in any given hour of flying per year. So aviation is considered relatively safe, and it kind of reflects that. So now we want to go ahead and create a set of graphs. So we want to see, first of all, accidents per year. We want to see all versus fatal plotted on that graph. So we'll go ahead and start by highlighting our x-axis data. Then we'll hold down the control key and highlight the all under accidents, all and fatal. All right, so now we're going to come up to insert, come down to chart. And now we wait a minute. And it suggested a line chart. I don't want a line chart. I want a scatter plot. So let's come down here and grab a scatter plot. Hey, there we go. Now we'll not bother so much with worrying about connecting dots. That's not something we're going to worry about. You'll notice that we've got this chart here. It's got years on our y-axis. It did not include a label. Let's come over here and chart and axis titles. We'll go to this drop-down menu and we'll look at our vertical axis title. And we would like that to be, I'd like that to be accidents. And for our chart title, we want to see, what do we want to call this? We want to call this accidents per year, all, we'll call it all versus fatal. All right, there we go. And there's our chart. All right, so our first chart is done. Let's go ahead and stick that out of the way there. And next we want to take a look at fatalities per year, total versus persons aboard. So again, we're going to highlight our x-axis data. And we're going to hold down the control key and highlight under fatalities, total, and those which happened aboard an aircraft. Now we're going to come back up to insert, chart, wait a minute, and change the chart type. I like a scatter plot. I just like it. That way, if there's any difference in the spacing on the x-axis, it'll automatically update that. We have all numerical data. I think we should be using a scatter plot for this. So here we are. And let's go over to customize because we're missing our y-axis labels. Go ahead, chart into axis titles. Let's change our vertical axis title. Let's call that fatalities. And for our chart title, let's call this chart title. Let's call this fatalities per year. And if I get that right, that's a semicolon. It should be a colon. And get your space. All right, there we go. All right, so that's our second plot. So now let's stick that out of the way. All right, last but not least, in this section, we're looking for accumulated fatalities. And we want to see a line of best fit with an equation. All right, so let's go ahead and highlight our x-axis values, our years. Now let's come over here to where we've calculated accumulated fatalities, hold down the control key and highlight that data. And again, we're going to come back up to insert, chart, and it's automatically assigned a scatter plot. Beautiful. It's called years for the x-axis and accumulated fatalities for the y, and our chart title looks fine. All right, so next thing, we need to find where it allows us to insert a line best fit. So we'll come over to customize, and now we'll dig around a little bit here. Let's check under series, see if it's there. Oh, look at that. Trend line. We want to add a trend line, and if we scroll down a little bit, label it. Let's label that with the equation. And let's go ahead and show the r squared value on that, so that way we can take a look at how well the data fits the line of best fit. It fits 0.991. It's pretty good. We've got a pretty good fit between the line of best fit and the data. That means that we've got a fairly good representation of the data by this line. Now you notice it calculated on average there have been, used for the slope of this line, it says that each year there have been about 479 new fatalities, which goes back and agrees roughly with our average number of fatalities of 486 per year. So it's good to see that those two data points line up, or at least reasonably agree. All right, so let's go ahead and put this chart out of the way. Last but not least, we have this extension. Now, if you get to this, great. If you don't, understood. And this extension, we want to create the same graph, accumulated fatalities per year, but we also want to see this on a logarithmic scale, so we can get a sense of how this data is changing over time a little bit better, right? We see, or how the rate of change is changing, right? So we see this data, this line of best fit, it's a line. We see the data, it seems pretty linear. We're not seeing big changes, big jumps in the number of accidents every year. If we take a look at that on a logarithmic scale, it helps us to understand how long it takes for the number of fatalities to double. We see a lot of logarithmic, a lot of graphing on logarithmic scales. Recently, as we take a look at COVID-19 case spread, it helped get a sense of how quickly the virus has been accelerating in its the number of cases we've seen. So let's go ahead and create the same graph. So first of all, we're going to highlight our x-axis data, our years. Now hold down our control key and highlight the accumulated fatality data. And we'll come up to insert and let's go to chart. And wait a second, and it automatically picked a scatter plot. Brilliant. Now we need to figure out, okay, where does it say I can have a logarithmic x-axis? So, or sorry, a logarithmic y-axis. So let's come over to customize and let's come down to vertical axis. Let's see if it's there. So scrolling down, oh look, it says log scale. So let's go ahead and click on that and look at that. It's automatically converted this to a logarithmic scale. And we can see that as this data proceeds, the rate of change, well, it's flattening out. And it gives us a sense that, yeah, the number of accidents per year, it's stabilizing. And I'll let you interpret that a little bit further on your own. So let's go ahead and toss this graph over here. And there we go. There you have it. We now have our full set of data, full set of calculations, and a set of plots to go ahead and use to interpret this data and understand a little bit more about about the U.S. general aviation accidents that have occurred between the years 2000 and 2019. All right, so there you have it.